I looked through the book in the sections that we need to review, and as I've told you before, this book sucks. So what they've done is they've gone around the world to teach you the chain rule and the other rule, and I'm really not going to do that, but I need to warn you that they are doing that. So when you look at your book, what they're doing, it's almost like if they give you, let's say, x plus 2 to the 4th power minus 3, and they say that's equal to f of x. This is what they're doing. They're telling you that this is a composition of f of x and g of x. And what they're saying is, they're saying that g of x is equal to x plus 2. Therefore, f of x is equal to what? X to the 4th power minus 3. And then they're giving you the longhand formulas of the chain rule to find the derivative of f of x, in which you have to take g of x, g prime of x, and multiply by g, let's see, f of g prime x multiplied by g prime. Okay? And if you do all that, you're going to get the chain rule of 4 times x plus 2 to the 3rd power times 1, which is 4 times x plus 2 to the 3rd power. Okay? And that's what they're doing. So this right here is what they're doing in the book. So when you see this, and you see all those formulas that they're multiplying, I might cover some, but I don't see really any point in it. And what they're trying to get you to do is think of U substitution for integration, but you don't have to go through and reinvent the wheel. What they're doing is they're reinventing the wheel by making you think of this as a composition f composed of g of x, which would be that you rewrite x with parentheses, and you plug in g of x, and then you get what you started with. So I don't really agree with what they're teaching, so I'm not going to worry about it. I'm going to try to pick out the most applicable parts of chapter 3 and put that on the test, but I'm not going to do a lot of what they do. Now, some of you that had different teachers for one, okay, let me ask the Anderson group. You had 130. Who'd you have?
Hannah Botchstein.
Okay, here or where?
Clemson.
Clemson.
Yeah.
Okay, did they follow this book?
Yeah, pretty much. We did it. We broke it out like that. And it confused.
Yeah.
So I like that way better.
Yeah. Well, I don't think you're going to have to use it that often. Now, there are times that you have to use for more complicated, but not right now. Who'd you have for 130?
Lee, Hannah.
Here or where?
Clemson.
And they use this
But
book.
yeah, they like followed it strictly.
Oh, yeah, they follow it strictly because Latory is like a god up there. Yeah. He was one of my teachers. I dropped him. Anyway, I didn't think he was all that myself. And his wife, she was not a nice person either. So anyway, I didn't have any part of them. Anyway, so what I want to tell you that the reason I want to tell you that is we're going to stick basically to the differential rules and the antiderivative rules, because to me that's most important, because you're not going to see the breakdown of the composition. You're not going to see that a lot, but we might go over a couple of them later after I've got y'all reviewed, really reviewed over the antiderivatives, and we're going to do that today. So let's go ahead and get started on that, and hopefully the loud ones will come in. They haven't come in yet. They'll come in about 15 minutes late. So we'll just worry about that when we get there. All right, so Next thing we're going to do is put some problems on the board. I went ahead and worked some out. Let's do... And I think we did one like this the other day. Or the other day, meaning Monday or whatever. Or whenever y'all started. F of x is equal to 2x cubed times 3x minus 5. Now, of course, that is a product rule. And again, most of the time in a calculus class, it's not whether you know the rule or not, it's whether you know where to apply it. So you know it's the product rule. You also know that you can distribute. So I don't care how you do it. If you distribute and use algebra first, you're going to get 6x to the fourth minus 10x to the third. And then you can call that f of x. And f prime of x is going to be equal to 24x to the third minus 30x squared. And that's using the algebra. Okay? 30x squared. Oh God, everything's working today. My gosh, the sky is going to fall. All right, so now you use the product rule. F prime of x is going to be first times the derivative of the second. And I'll put a accent mark there to remind us to take the derivative plus the second times the derivative of the first, which would be 2x to the third, and I'll put a red accent mark prime part there. So now we take 2x cubed, and what's the derivative of 3x minus 5? 3 plus 3x minus 5 times the derivative of 2x cubed, which is 6x squared. Now you got to rely on your algebra. 6x cubed plus 6 times 3 is what?
18.
18. So that's going to be 18x. Yeah, thank you. The door messed me up. 18x cubed. Blame it on the Russians. 18x cubed minus 30x squared, and 6 plus 18 is 24x cubed minus 30x squared. And you would be surprised. There's a lot of first and second year calculus students that have now just realized that you can do it two different ways. Okay? You can always rely on your algebra. Always in calculus, because if you suck at algebra, you're going to suck at calculus. Did Noah ever show up?
Yeah, I'm right here.
Okay, good. All right, so let's do a nerd. And let's just throw the sign in there because we do want you to be able to take the derivative of the sign. And I'm just going to throw one in here. F of x is equal to x times the sine of x. Okay, now you're going to have to use your calculus here because you can't use algebra. So go ahead and do the first times the derivative of the second plus the second times the derivative of the first. And we're just going to spend today, well, we've spent a little bit of time, but that was a cluster. Monday was a cluster. It was a cluster, so we're not even going to count Monday. So we're just going to count today as a review. And we're going to spend Monday going over any homework problems. It's because I'm going to put a bunch of review problems up. I didn't do it yesterday because of Monday was such a mess. So we're kind of counting this like the first day of class, only I'm not going over all the stuff, all the handouts. We're just going to do the review. I'm going to put homework up, probably 3 or 4 sections, or I might just make one section with like 30, 50 problems or whatever. I don't know what I'm going to do. But I'll put them up, and then we'll spend Monday going over any that you had a problem with. and then we'll move on, because this section, where's that outline? This section, y'all count the sections. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like 12 sections, but basically we're going over about 6 sections, because this book, it just draws everything. It just draws everything out, and we're really not going over a lot of stuff that you haven't seen before. So just bear with me. X first times the derivative of the second plus the second times the derivative of the first, and that's going to be x times sine of x. I'm sorry, cosine of x. Up. There it goes. It's not working anymore. Oh well, so much for that.
What's not working?
My eraser's not working anymore.
Oh, I thought we weren't working.
Oh yeah, no, you're fine. Everybody's fine, I hope. Yeah, everybody's still there. All right, cosine of x plus sine of x. I'll do this derivative for you, times 1. There you go. All right, so that's x cosine of x. Oh, horse pucky. X times cosine of x plus sine of x. I love this board. It's a whole lot better than that other board, the other board we used last semester.
What was wrong with that board?
It didn't have the finish on it that this one has. This one has some kind of a finish on it. I don't know what it is, and it's a whole lot more durable, so it doesn't bend. So the writing is a whole lot easier. And they ordered a board, and this is the IT department. They ordered a board, and it has extra space over here, so you can write with a marker if you want to.
Right. Smart board.
Wow, what a concept.
Yeah, it's not a smart board. It's a projector that's doing
Yeah,
it.
the projector is doing everything. Yes, not a smart board. The projector is doing everything. So the board is still a whiteboard. So some of the less technology-driven instructors can go back to the whiteboard. Okay, capiche? Everybody good with that one? All right, let's go with the quotient rule, and then we're going to get into some more complicated ones. F of x is equal to 2x cubed over x minus 5. And the reason I'm spending a lot of time on this, because if you're going to suck in 230, it's going to be started from this first test. And I got to make sure everybody has the basic rules. Then after I go over the basic rules, we're going to get into a little bit of the problems that they have in the book, so you can see the application of the rules into the business end of the calculus. I don't think you should jump right into the business end of the calculus if you don't have a good review of the basic rules of the calculus. So, believe it or not, I'm trying to watch out for you instead of, discourage you and tell you that you're losers and tell you should quit. I'll do that later. Denominator times numerator prime minus the numerator times the denominator prime over what? Denominator squared. Where's the loudmouths? They got there yet? Easily? They got there yet?
Talking about you. You talking about me?
There they are. They're here. The camera's not facing you, so I didn't see you when you came in.
You better watch your mouth, boy.
I tell you what. Where's your brother at? Is he there too?
You know you don't come to class.
Oh, he's at Waffle House. Probably taking off that late night drunk.
Mm-hmm.
All right.
Probably right.
So we got x minus 5 times 6x squared brackets, 2x cubed times 1, I'll do that one for you, over x minus 5 quantity squared. And that's going to give us 6x squared times x is 6x to the third.
Yeah, it's the same thing.
Minus, quiet, 30x squared.
I thought that was kind of weird. Yeah.
What are y'all talking about? Oh, I'm sorry. I didn't mean to interrupt y'all while y'all were talking.
We were talking about movies, you know.
Okay, well, don't talk about that. We're talking about calculus right now.
My bad.
All right,
that's
minus 2x cubed over x minus 5 quantity squared. Right now, there's not even good movies on right now, so I don't know what you're talking about. I did get to see the Avengers movie. I don't know how. I turned my Fire Stick on one night, and it was the night it was the day it was opening, and it was on there. And I said, "Oh, I'm gonna just see a preview." And man, I hit it, and that good movie come on. I said, "Oh crap, I'm gonna watch this." It's a pretty good movie.
What did you think of it?
Huh?
What did you think of it?
It's okay. I'm not really into those kind of movies. I'm into horror movies and stuff like that. So it was all right. I still think Captain America needs a girlfriend real bad. He needs one real bad. I still think that. Anyway, 6x cubed minus 2x cubed is what? 4x cubed? Minus 30x squared over x minus 5 quantity squared, and I'm not worried about simplification and reducing. That's I'm not worried about that. I'm just worried about if you can get to that point right there, we're good. So what movie were y'all talking about?
We were talking about Infinity War, man.
Oh, is that what y'all were talking about?
Yeah, of course.
Well, like I said, there's not really any good ones on. That's the only one that I even...
Did you see the one with, what's the one about being quiet?
Quiet Place?
Quiet Place?
Yeah, Quiet Place.
Yeah, I saw it on Fire Stick, and I'm like, golly, this is like no sound.
Yeah. Yeah, what'd you think of it?
It was okay. It was okay.
Well, Deadpool comes out Thursday. The first one was pretty funny.
I'm psyched about Deadpool.
Oh, yeah, I'm really, really excited about that. No, I'm not. I could care less.
He's my favorite hero, man.
Yeah.
I want dang old horror movies to come out, some good ones. There ain't none come out.
I care about horror movies.
Yeah, I watched one yesterday. I watched one, Good Bad Pedestrian or something like that. That one was kind of boring.
Which one?
I think it's like Bad Pedestrian or something. It's like this dude has this girl locked up in his house, and the guy finds her because he's robbing him, and then he has to go to the FBI and try and get her back. But it wasn't
I
that
haven't
good.
seen that one. I haven't seen that one.
One tap.
But I stick to my horror movies. I stick to the haunted houses, the possessions, and I like Michael Myers and Jason. That's about it.
So you like The Conjuring at all?
Yeah, I love The Conjuring. I wish they do more of those. I didn't care too much for what was the one? Oh, I'll think of it in a minute. With a boy, it was kind of like
Insidious?
Yeah, I didn't like Insidious. I watched all of those, and I didn't care nothing about it. Yeah, it was pretty good, but that's Stephen King, so I like all of Stephen King. So, but yeah, Insidious. If another one comes out after the fourth one? I think it was the fourth one.
Hey, you liked it, didn't you? I can't remember. What was your?
I liked it. I liked it. I don't know why they had to. I don't know why they had to put, and I'm not trying to sound like but I don't know why they had to put all the cussing in there. I don't know why they had to do that. I mean, to me, that just took away from the movie because the original movie didn't have all that in there. But I think it was a good movie. I liked it.
I thought they did a good job.
Yeah. What's better, the original or the new one?
Yeah. Do you like the new one or the original better?
I kind of like the original one better because of the clown, what's his name that played?
Pennywise.
Oh, what's his name? I can't remember the guy's name, but he was more funny to me than the new Pennywise, but I could be
He's
wrong.
not supposed to be funny.
Yeah, he was a little bit funny in the first one, or I took it that way, but maybe I'm just deranged.
Took it the wrong way.
All right. So here is a way that you would. This is a business application type problem that I found that was halfway decent. So the cost of making something, widgets or whatever, is equal to 1/4. I don't know what's happening to this pen all of a sudden. Now it's okay. I just put a battery in this thing yesterday, Monday, and now it says it's dead.
Yeah, like
Bushings.
now for like interchanges throughout because they're adding stuff.
What'd you say?
For sure, like we're discussing it.
Yeah, we got it. We got
Hey,
it. Quit.
we're through with
We don't
that.
think it's
This is this it on the screen? No, it's math. When I start discussing
I'll
math, that means you shut
I
up.
freaking wish, man.
Okay? Plus 4x plus 100. And they want to say producing how many units will result producing how many units will result in a minimum average cost per unit. Okay, so the average cost, whenever they ask for the average cost and they give you a cost formula, you're going to divide it by X. So the average cost, and that's a rule that you need to remember. C bar, X bar is the mean, C bar is the average cost. It's going to be equal to 1/4 X squared plus 4X plus 100 over X. Now right quick, I want you to divide that polynomial by X, and I want to see what some of y'all come up with because some of y'all are going to screw it up. But go ahead and try, and let's see what you get. And then take the derivative of that function.
I win.
So if you hadn't screwed it up, you're going to get 1/4 X plus what? 4 plus 100 X to the what? -1. And the reason you have to the -1 is because you want to rewrite it because you're going to take the derivative and you need that exponent up there. So I guarantee you, if I have 20 students in the classroom, which I don't, but I'm using 20 as a round number, I guarantee you probably 5 students don't have this right here. They might have some form of it, but you need it like this so you can take the derivative. Again, that's one of those things that you have to know to do when you're in calculus. Now, my 130 students, what have I always told you about radicals? You remember what I told you about radicals in calculus? Somebody say it? Okay, so I failed as a teacher. Because y'all don't know. Radicals in calculus don't what?
Mix. They don't mix.
Don't mix. Oh, good. One person. Okay, one person remembered. But that's one of those things that you have to remember when you're doing calculus, just like this exponent. The denominator has an exponent of 1. That does you absolutely no good when you're talking about calculus. So you bring it up, x to the negative 1. Now, what is the derivative? C bar prime is going to be equal to 1/4 plus what? Well, negative 1, what does it come out to be? Be negative 100, make sure I didn't mess up. Be negative 2, exactly. You're gonna be a negative 1 minus 1 be negative 2, so that's going to be 100 over x squared. Now, what does minimum mean? When you're talking about minimum in business, you're thinking about the first quadrant. Why are we thinking about the first quadrant of a graph?
Was that positive 100 because it's a negative?
Well, because that would be positive profit.
It should be negative. Yes, negative. Why? Somebody said something about the first quadrant. What did you say?
I mean, wouldn't that mean it's positive profit and you're producing something if it's in the first
Exactly.
quadrant?
In the first quadrant, everything's supposed to be what? Positive. And in business, you want a positive, but what is the minimum in the first quadrant? What number represents the minimum in the first quadrant?
0.
0. Very good. You are an exceptionally talented student. 0 is equal to 1/4 minus 100 over x squared. Now you have to rely on 100% what to solve this equation? Algebra. So go ahead and finish it. What do we do? I can't. A negative, that x squared's on the bottom. I don't know what to do.
How'd you get the x squared on the bottom? How'd you get the x squared on the bottom?
Well, it was x to the negative 2. When you take the derivative of 100x to the negative 1, bring the negative 1 out front. That'd be negative 100.
Yeah.
X to the negative 1 minus 1.
You can't just leave it.
Negative 2. So that negative 2 comes down.
Yeah, okay.
You can leave it as negative 2 if you like, working with whips and chains and stuff like that. Yeah, but it'd be a whole lot easier with bring the x to the negative 2 down, and it would be. But now you got to clear the common denominator by multiplying through by the common denominator, which is what? That means I want y'all to interact with me when I ask a question. Not all of you suck. Some of you should know that the common denominator is 4x squared. So multiply by 4x squared, you're going to get 0 is equal to what? Well, 4x squared divided by 4 is what? Thank you for the interaction. I appreciate it. 4x squared divided by x squared is 4 times 100 is what? So x comes out to be 20. Why did I not pick negative 20?
Because it's not in the first quadrant, you wouldn't want to produce at that point.
Thank you. You're starting to think like a business person. So 20 is your magic number. And now you can take 20 and do what with it? Plug it into what? Both the equations. You can plug it in here to find your minimum cost. You can plug it into here to find the cost throughout the whole doojiggers, okay? So I'm just going to put BS right here, which means in our world, in the mathematical world, back substitute into both the formulas. Turn that red, back substitute into this formula, and then back substitute into this formula. 20 squared is 40, 100 divided by 40, 14. I think this comes out to be 14, I think.
That's what I got.
And 14 times 20 is 280, so you should get 280 for the cost. Now that is again, it's a practical application in the business where, and then you need to write this down. There's two things that you need to write down. When you want to find the average cost per unit, you divide by X. So you need to put right here, average cost per unit, you need to put out here, divide by X, and that's what I did right here. Then, when you get that, take the first derivative of the average cost, and that will give you your polynomial to solve.
What happens if you're 4x squared? How you got the x squared minus 400?
Okay, well, 4x squared times 0 is 0. 4x squared leaves x squared. 4x squared, the x squareds cancel. 4 times 100 is 400.
Oh, I got you.
And don't worry, that's a question that's the algebraic question. And what gets rusty? Algebra. Algebra always gets rusty, and that's what students have to deal with. So if you don't want to suck at calculus, make sure you know your algebra. And make sure you ask questions, because it'll come up. It'll creep up on you. Where is my... Here it is. I got a few more. I went to Google and pulled out a few more derivatives. Let's do these, and then we'll move into some antiderivatives. Another product rule, x cubed. I don't want to use black. Somebody will bitch about that. F of x. I can't see it. Let's go with x cubed. X cubed plus x plus 1. And multiplied by x minus 1. Now, why would I put that one up there as another example? Because some people look at it, and what's the first thing they say when they look at it? Oh, God, that's long. Don't do that. Just go through and take the first first times the derivative of the second plus the second times the derivative of the first. One bad thing about calculus is that sometimes the problem looks more difficult than what? Than it is.
Than it really is.
It's real easy to intimidate students in calculus with just the first look at the problem.
Thank you.
No yawning in class.
You're going to kick me out?
Yep, leave. First times the derivative of the second plus the second times the derivative of the first. And of course, what could you use if you didn't want to use calculus? What could you use first? You could use algebra and use the distributive law. And that's not a bad idea to use both, because some of you may be a little bit rusty on your algebra. Even going through Calc 1, you may be still rusty. So it wouldn't be a bad thing to go through and do it both ways. But that's the difference between somebody that plays in a recital and there's no missed keys versus somebody that plays through a recital and there's like 5 missed keys. That's the difference. Person that practices more, they're going to sound a whole lot better, and they're going to make a whole lot better on the test. And they're going to be the one that you don't copy off of, and the one that the one that you don't get all your work done and get somebody to do all your work. You don't, when you're in the real world. I'll shut up. I'm not going to say that. Shut up. All right. So x cubed plus x plus 1 times 1. See? That's 1 right there that just went down to nothing because, and then x minus 1 times 3x what? 3x squared plus 1. And then you got to rely on 90% algebra. X cubed plus x plus 1 times 1 plus 3x cubed plus x, be a minus x, plus x, minus 3x squared minus 1. Make sure I didn't mess up. And 1x cubed plus 3x cubed is 4x cubed. X plus x is 2x. Negative 3x squared. And the 1's cancel. So you're left with that answer. Yes, sir.
The x to the third plus x. Shouldn't that one binomial?
Where?
The x squared plus 1. Shouldn't that one drop?
The derivative here is 3x squared. The derivative here is 1. The derivative here is 0. That drops off.
Oh, okay. I dropped them both.
Yeah, just drop it. Just drop it.
On it.
That way you don't have to do the problem.
3 from. Oh, never mind.
All right, check. Make sure y'all's answer looks like mine. Let's see.
So,
Well, I don't have the answer there. Oh yeah, they got to like the third step and they just quit. They didn't even do the algebra, so they just did the calculus. All right, let's do narrative. Let's do one that's got something mixed in with it. F of x is equal to x squared plus 3 times x squared minus 10 to the 10th power. Now what's the kicker with this one? Can you use algebra? Yes. Do you want to?
No.
That would be a hell to the no. Not just no, that would be a hell to the no. Why?
That exponent?
That 10 exponent means you're going to have to multiply that thing out 10 times, which means you got to use the distributive law like 5 times. Okay? And then you're going to have to use algebra more than that. So this cancels out. This is another one of those things where you look at the problem and you assess it and you say, okay, algebra's out. So that means I've got to rely on power rule, product rule, quotient rule, and chain rule. And when the power is so big that you rule out algebra, that defaults you to the chain rule. So first times the derivative of the second plus the second times the derivative of the first. All right, take off. Do not worry about doing algebra all the way to the end. I just want you to get a simplified calculus version. Do not expand it out. Don't do that because that'll be too much. Where's Farmer John beating on the nail? Where's that? Is that easily or is that penalty?
No, that's me.
Man, us, man.
Oh, okay. Just tell you people to come on in and join the class. You know.
That was the clock.
I'll mute my mic.
No, I'm just kidding.
I'm telling you that he would complain about that clock last semester. Like that's the noise it was making.
Yeah, that hammer. That's what that clock. It easily sounds like.
That clock was really loud.
It was.
They just took it off the wall.
Yeah, I asked them to yesterday.
Did you really?
Yeah.
Oh, I was just.
The lady that works in the front office, so you could hurt her feelings, and she started crying, and I said, "Oh well." No, she took it down. She said, "That's fine." But as long as you don't start rattling papers and crumpling up papers and doing the book bag on the table, we're okay. But good gracious. I remember last semester at the Pendleton campus, somebody was crumpling up papers. Oh, my Lord.
Well, when we have to take our last in-class test and everybody pulls out a piece of paper, it's like the loudest thing you've ever heard.
It's like going, yeah. And which I don't want to do that, but these I was asked last semester, did you give your business calculus, did you give them a final exam in class? I said, yes. Did I count it? No. But anyway, I ain't going to do busy work. They can just fire me. I'm not going to do it.
Does he not count it? Hell yeah.
I think bureaucrats, you know what I think? I think when you suck at teaching, you become a bureaucrat. I really think that. Or some people call it administrator. X squared plus 3. And that comes out to be, I'm going to put this in brackets, 10 times x squared minus 10 to the 9th power times, what's the derivative of x squared minus 10? 2x, and I'm going to put that in brackets, plus x squared minus 10. And what's the derivative of x squared plus 3? 2x, Hubert. Thank you, class.
I think there's supposed to be 10, 2x minus 10.
Okay, hold on. Where at?
It's at the second one where it says 2x squared minus 10. You're forgetting the 10.
Yes, exponent.
Right?
Right here?
No, next part.
Right here?
Yeah, shouldn't that 10 be dragged on too? So it's x squared minus 10 to the 10th power. That's technically.
Oh, thank you. I didn't write the 10. Thank you. Thank you. I was looking down. I'm sorry. Yeah. Don't forget your exponent here. Don't be like your teacher and forget it. All right. So we got x squared plus 3. And then we got to clean up in here. 10 times 2x is 20x times x squared minus 10 to the 9th power. Plus 2x times x squared minus 10 to the 10th power. You can leave it like that. You can distribute this 20x with this x squared plus 3 if you want to, or you could just finish it by saying 20x times x squared plus 3 times x squared minus 10 to the 9th power plus 2x times x squared minus 10 to the 10th power. I would take that as an answer, or you could have some form of that. All right? Any questions on that one? And there would be several forms of that answer that you could make this the answer. Now, those of you that have used WebAssign, y'all know it sucked, right? Okay, so be prepared to write your answer several different ways, and even when you write your answer the same way that they write it, it'll still mark it wrong. So that's when you need to come see me and I'll fix it, okay? But what did, you took it to Clemson, what did y'all use? Did y'all use WebAssign? Did they like it?
They loved it. They loved it.
That figures.
Yeah.
Yeah, that figures. It's kind of like the movie critics that say that this movie sucks. If the movie critics in New York say that this movie sucks, that means what? It's a very good movie.
It's going to be gas.
Yeah, it's going to be a very good movie because they don't have no touch of reality. And if somebody says that WebAssign is the greatest thing since sliced bread, they don't have any concept, because WebAssign is, and I've been dealing with this stuff since '96. WebAssign is the worst, I don't know what you call it, supplemental program or website that I've seen in 20 plus years. Now, I don't know why they say it's better. They just like it, or they never use MyLabs Plus.
I don't know. I think
MyLabs Plus is confusing to me.
You kidding?
But I've never used it before except senior year.
Okay.
I used it like.
Well, for a teacher, it's more user friendly. Like where I have to give y'all 3 exams. Y'all know my 130 and 109 class. I have to give y'all 3, A, B, and C. So it'll take the highest of the 3. And MyLabs Plus, you don't have to do that. You just make one test and give it 3 attempts, and it mixes it up and does it in different forms, and it'll take the higher of 3. But with WebAssign, you have to make 3 separate tests.
Yeah, and if you don't take it, it gives you 0. Like, I mean,
Yeah, it can.
Yeah.
But it's a pain. All right, here we go. F of x is equal to 3 times the cube root of 2x squared plus 1. Actually, this is not the product rule. You can pull that 3 out and just take the derivative of the radical. But this is, again, you have to assess it, and the first thing you should say is I've got to change that radical because radicals and calculus don't mix. So what would we change the radical to?
Like a 1/3.
2x squared plus 1 to the 1/3, and now you've got the chain rule.
Wow.
So that's going to be 1/3 f prime of x is equal to 1/3 times 3 over 1 times 2x squared plus 1 to the 1/3 minus 3/3 times, what's the derivative of 2x squared plus 1? 4x. And now clean it up.
Yeah, I got you.
Now, I put those extra steps in there because some of y'all, when it comes to fraction, y'all break an anvil with a banana. So I put everything out there so you would see, how not to mess it up. So what's 1/3 times 3? 1. And then 2x squared plus 1. And what's 1/3 minus 3/3?
-2/3.
Times 4x. All right, now I want you to write it in the correct form of the answer. That's including a radical. I want you to write the answer in the correct form, including the radical. Because that's a step that some of y'all don't break down with a banana on that one too. I say y'all, I don't mean this class, I mean students in general. I have to put that disclaimer out because somebody thinks I'm talking about them. So I'm snowflake. So I'm glad that we're not running into any snags today, except for the two people that messed up our screens today. But other than that, that's fine. And the hammer, I can't forget the hammer. Making noise. So it's going to be 4x over 2x squared plus 1
Speaks too soon.
positive 2/3 power. And we know that's exponent over index, so that's going to be 4x over the third root of 2x squared. What was that? What was that? It had to be the Easley campus. Easley, have you muted?
No, you froze. Remember
What?
how you said that we weren't running into any snags?
As soon as you said that, the screen froze.
You immediately froze.
Okay, is it doing better now?
Yeah, like we can see what you're writing, but you're not at the board at all, and all our cameras are just frozen. But we can see what you're writing.
Damn Russians. 2/3. Okay, there's the answer. I'm sorry, to the second power. Well, I'm not going to mess up the class because it's going too good, so y'all just going to have to watch the writing, and that's your final answer. Now make sure you understand what I've done, because a lot of students, when it comes to radicals, y'all mess it up. And gotta throw an E in there, so y'all can remember how to do E. So how about f of x is equal to 4e to the 2x. Again, you could use the product rule, but all you got to do is pull that 4 out to the front and just take the derivative of e to the 4x, e to the 2x. And actually, it shouldn't take you but a few seconds. 4, and I'm going to put a parenthesis here because I'm going to take the derivative of e to the 2x. Well, what's the derivative of any e term?
Same.
The same term. So the derivative of e to the 2x is e to the 2x. But remember I told you to put this in parentheses so that you will remember that you have to use the chain rule and take the derivative of what's inside, which would be what? 2. And I'm going to put that in red so you remember that you took the derivative of what's inside. So therefore, your answer is 8 e to the 2x. And what students do on this one is they do this, 4e to the 2x, and that is incorrect. Okay? So that's just a refresher on e. And now let's get to the antiderivatives. three easy ones to do. Antiderivative of 4x cubed dx. Antiderivative of 7 dx. And the antiderivative of 2 over x dx. Now, with the antiderivatives, you have to remember to put things back in the form of a radical, or you have to remember to put the negative exponents back in its positive form. What do you have to remember about the integrals or the antiderivatives? Also, those two things, but what do you have to remember to put in the answer?
Plus C.
Plus C. Always remember that, because you're going to have some teachers, and what will they do? If you don't put plus C in the answer, what will they do?
Count it wrong.
Okay? So remember that. And the opposite of the derivative is the antiderivative. So that means instead of subtracting from the exponent, we're going to add, and then whatever we add, we put that on the bottom also. So, what's this one going to be? 4 times x what? X to the 3 plus 1 over what? 3 plus 1 plus C.
Hey, everything's frozen for us now. We can't see your writing anymore.
Okay? What I'll do is I'll take you out and I'll bring you back in.
Alright.
See if that unclusters it, okay? Here we go. Now, to let y'all know, this only has happened 2 times last semester, so.
Yeah, this never happened.
Okay, I just took you out easily. Now I'm going to bring them back in. Easley's offline. They need to get back online. Come on, Easley. Let me just call them and see if they come back. Nope. If it says it's offline, you ain't going to get them. Try to call them back up. There we go. Okay, Easley, you there?
Morning, Hubert.
Now?
Yeah, I believe so.
Okay, what about the, everything good?
Well, I'm still opening stuff up.
Okay.
Move your arm. Yeah, you're moving.
Yeah, you're good.
Okay, good.
You're moving.
All right, so the antiderivative there simplifies to what? 4/3 x to the 4th. Somebody check me. 4/3 x to the 4th plus c. This one, you can actually break this one up into 7 antiderivative of dx. And what's the antiderivative of dx? X, Hubert. That's right, class. So, or you could just write this as x to the 0. And what is 0 plus 1? 1 over 1, which is 7x. What's the first thing you do on this one?
Bring the x up.
You rewrite, bring the x up, exactly. The antiderivative of 2x to the negative 1 dx. The 2 come out. Antiderivative of x to the negative 1 dx.
Yes, sir.
Something wrong? Still working? You okay easily?
Yeah, we're good.
Okay. 2x to the what? What's negative 1 plus 1?
0.
0.
So that's 2x to the 0. So it should be, did I do that right? I think I did it right.
Straight.
It ain't hard to have done one like that. Make sure. No, that's not right. Okay. The antiderivative, rewrite this right here. That's the natural log. I knew something was wrong there. You don't come out with that. This is 2 times the antiderivative of 1 over x. And what's the antiderivative of 1 over x? It's easier when I say this. U over du, or du over u. That's what I'm used to seeing. Du over u. That's what that is right there, which is equal to the natural log of u. That's what I'm used to seeing. Sorry. So that would be 2 natural log of x plus c. Now here you need to make sure you make a note. You need to make a note that the antiderivative of 1 over x is, which I gave you those last semester. If you were in my 130 class, I gave you a whole list of them, which you probably threw away, but that's okay.
Is that parentheses or?
Absolute values, because you can't take the natural log of a negative. All right, let's try another. And again, what I'm trying to do is I'm just trying to refresh the memory. You've had, what, 2 weeks off? I'm just trying to refresh your memory and assessing and what to do, when to do it. I'm not reviewing over what you learned. I'm just making sure you understand when to do what. So, antiderivative of 1 plus 2x minus 4x to the third dx. What do you do? It's the antiderivative. What do you do? What you need to be asking yourself. John lives. John lives. Okay. And you're Jeff's. So John, what does he do?
He does.
How many kids he got?
He has, well, he got a divorce probably like 5 or 6 years ago, and he adopted Jackson and Martosha, which was sons, and they had a kid, Kat. So technically he has 2, but he only has 1 biological.
Okay.
If that makes sense.
Okay.
Yeah.
A little bit of sense.
Yeah. Yeah, he's a great guy. Then my other brother is out in California now.
That's the youngest.
Justin.
Yeah, I didn't know him.
Did you know Jay?
Yeah.
Okay, yeah. Jay's still at Kings Mountain, maybe? We don't see him that often.
I don't see any of them. 2 of them live right nearby. Yes, sir.
I didn't learn antiderivatives at all, so I have no clue where you start. I mean, I'm trying to break down these other ones, but I don't even know.
Okay, well, okay. So,
I didn't learn any antiderivatives either.
well, y'all took it at Clemson. Y'all should be
We didn't.
10 times above us.
We didn't do any.
That's the last unit. Wasn't that the last unit, guys? In 130?
Yeah, it was one of the last ones.
Yep.
Yeah. Well, Clemson didn't cover it, y'all, so I guess we don't have to cover it.
Sweet.
I thought Clemson professors covered everything.
We get TAs. They don't know.
Well, listen, when I was taking mathematics there, the TAs are the ones we tried to get because the professors were terrible. I had one professor, Dr. Ruckle, he'd been up there for like 170 years, and all he knew how to play Tetris. He would come into class, he would write the assignment on the board like Russell Crowe on Beautiful Mind. He would write the assignment on the board, leave, and then you go ask him a question if he's playing Tetris in his office. And then I had another one, he taught calculus, he grunted. That's all he ever did was grunt. Oh well, what did I do with my problem? There it is. All right. Since you have not had, haven't had. How many? Okay, Easley campus. How many of you have had antiderivatives? I don't. I know my 130s did.
Very quickly, but she didn't teach it at all, so I'm also kind of lost.
She went over antiderivatives quickly.
I learned it, but it's been a full semester.
Not very good at it.
Okay, so Easley campus.
Got 3 people saying they don't know what they're doing. So.
Okay, 3. How about you, Pendleton?
I learned it. But it's been a full semester, and I didn't really get it the first time I learned it, so.
Same.
Okay, anybody else at Pendleton? I know we had 3 or 5 up there last time. Anybody else?
Yeah, there's me there. I also haven't.
You don't remember them, or you didn't have them?
No, we did not cover that at
Oh
Clemson.
boy, chilling.
Oh, okay, my Math 130 students, y'all are ahead of the curve, aren't you?
Look at
Hell
you,
yeah,
being
we
a good
are.
teacher.
I ain't believing that.
That
Wow.
means can I leave?
We did too.
I
We covered the second, we covered everything.
You cannot tell.
Okay, all right. Well, let me back up once. Well, I can do this one and integrate the first law of antiderivatives. Okay. I'm gonna skip going what you're finding, but you're finding the area under the curve. Okay, that's what you're finding. The first rule of antiderivatives is you can break this up into 3 separate derivatives. I'm going to try to integrate 2 or 3 rules in here at one time. So Math 130 students, especially mine, try not to talk, okay, while you're bored because I've already gone over this, okay? So
Yes, sir.
x to dx minus antiderivative of 4x cubed dx. Okay, that's one of the first basic rules of antiderivatives. If you have 3 or 4 of them, the sum of any terms, you can break them up into separate ones. That's one of the first rules. The second rule is if you have a constant, you can pull it out, just like derivatives. So that would be 1 antiderivative dx plus the 1 antiderivative of x dx minus 4 antiderivative of x cubed dx. Oh, sorry, that's 2. Sorry. Okay. So there's 2 basic rules that you pretty much learned with antiderivatives. If you have an antiderivative with 3 terms, you can break it up derivative, you can break it up into 3 derivatives. Okay, that's the first 2 rules. The third rule is the power rule. And the power rule of antiderivatives says that you take a to the n, you're going to add 1, and then you're going to put a denominator of the same thing of n plus 1. And that means that here I've got, and this is what I told my 130 students, always go back to the basics when you're worried about derivatives and antiderivatives. If there's no x there, then you put x to the 0. If you have an x to the first power, you put 1 there, and this one has an x to the 3. So now you're ready to do the power rule. So this one's going to be 1, and I'm going to put brackets here, and I'm going to take the antiderivative. That's going to be x to the 0 plus 1 over 0 plus 1 plus 2 brackets x to the 1 plus 1 over 1 plus 1. What's that? Minus 4.
That was my beer.
Oh, okay.
Crushing them back here.
Okay. 3 plus 1 over 3 plus 1. Somebody told me to go to try the PBR. That's the only beer you can drink now is PBR. That stuff tastes like daggum Keystone. That stuff's nasty.
Yes, it is.
And I don't understand. I guess it's a fad thing. You know, kind of like motorcycles was a fad thing. Then the tattoos was a fad thing first. Then the motorcycles, and now it's beat up old trucks that look old. And you got to drink PBR, and it's. I threw it away. I mean, I did. I threw it away. I got a 6-pack and I tried one, and it was like nasty. And I just threw it away.
Did you throw the 6-pack away?
Yeah, it was nasty. Have you ever had
You should have
PBR?
sent it my way. Come on now.
Have you had PBR before?
Gross beer, I don't care.
It's gross.
You would have. It tastes nasty.
Hey, we're on a college budget here. We'll take any beer we can get.
Oh, yeah, that's true. When I was in the Marine Corps, it
We'll
was.
also take any beer we can get because it's legal for us to buy.
Okay, yeah, that's true. But anyway, when I was in the Marine Corps, it was
From
Keystone.
Montana.
Keystone and Black Label. Keystone and Black Label was the.
Yeah, I'm like 24-year-old.
Anyway,
Schlit.
I don't know what made me think of that. All right, so this gives you x to the first over 1 times 1 plus 2 x squared over 2 minus 4 x to the 4th over 4. Now simplify it. And don't forget the C. So, what's x to the first over 1? X. What happens to these 2's right here?
Cancel.
They cancel. And the 4's cancel. So you're left with plus x squared minus x to the 4th. That's the basic 3 rules of integration. Integration and antiderivative are the same. Now, for those of you that did not get antiderivatives, what 2 types of antiderivatives are there? I mean, for those that did get it, there's 2 types of antiderivatives. And remember what they are? One starts with a D and the other one starts with I.
Integrals?
Say it. You almost got it. What?
Integrals?
Okay, that's integral and antiderivative is the same thing. But what 2 types are there? There's one with numbers and one without numbers. What are those 2 types called? One starts with a D, the other one starts with an I, which is the opposite of the D word. Anybody remember?
No.
D-E-F, I, definite, and you wasn't in my class.
Indefinite.
I appreciate it. I appreciate
What's the
it.
opposite
Take
of
that
definite?
with some TAs that were in my class. All right, definite, and can you figure out the other one?
Indefinite.
Oh man, I tell you what. All right, so what is definite and indefinite?
Easily holding it down, Hubert.
I tell you what.
Here's now, I got it.
Definite means that you have a defined area, and that means that you have an A and a B. All right. So definite would be the antiderivative from 0 to 4 of 4x to the 3rd power dx. That's a definite integral. Why is it definite? It's definite because you have an A and a what? A B. You have a start and you have a what? A finish. Now, if you'd had me in 130, you would have seen the introduction that I give with this, the area under the curve with the Foxtrot comic, finding the area of a rectangle. And there's 2 ways to find the area of a rectangle, length times width, or you can take the antiderivative from 0 to 20 of x, 3x, or whatever it came to be. You're finding the area under a curve, all right? And this is your x from 0 to 4. You're finding the area under that curve from 0 to 4. It's kind of like this. From 0 to 4, and the x is equal to 20. and you take the antiderivative of 20 dx, and that'll give you 20x, and then you take 20 and multiply by 4, and that's going to give you 800, and the area of this is 800. Okay? 800 square feet. All right, so this is your A, and this is your what? B. Can I plug in 5? No. Can I plug in 4.5? No. Your parameters are set from 0 to 4. You have a defined area. So that means it is a definite integral, which means you have an A and a B. Do you know how long it took me to figure that out at Clemson when I was in first semester calculus? It took me about 3 weeks after the so-called introduction to integrals in the class.
I just learned it in 10 minutes.
Dr. Harden. If you go to Clemson, in the bottom floor of Martin Hall, they have a little plaque beside his office, one of the little plaques, and it shows him and it don't show him grunting. They should have put a little voice box right there, and you punch it and it goes, that's what he said. That means you know what to do here. Can you believe that somebody like that taught for like 800 years at Clemson?
800 years.
That's fact.
Yeah.
I read that on
Dr. Nowak, who taught me
fact.
statics and dynamics when I was in engineering, I made a C out of both of those courses. Statics, he'd been there for like 72 years.
Did not, but
Exactly. Well, they have no wives. They have no life. They have no wives. That's what's wrong with them. They have no wife or girlfriend. Some of them need both. Anyway, so we got 4x to the 3 plus 1 over 3 plus 1 evaluated at 0 and 4. Now, make a note here for those of you that's never seen an antiderivative. When you have a definite integral, you draw this little line right here. When you take the antiderivative, this means I'm going to evaluate this guy at 4 and 0. Evaluate means subtract. Now, why does it mean subtract? Well, I'm going to give you an example of why it means subtract. Let's say this is Spartanburg, this is Greenville, and this is Anderson. We know that Anderson to Spartanburg, I'm just going to use, okay, I know I have some people in here that's going to say, well, that's not right. Shut up. It's examples, okay? All right. Let's say 50 miles for mathematical purposes. It's easy to take away from 50. And we know that Greenville, from Anderson to Greenville, is 30 miles. So what is the distance from Greenville to Spartanburg? You do 50 minus what?
30.
Okay, the key word here is what? In order to find the distance from Greenville to Spartanburg, you have to subtract. When you're finding this distance right here, you are going to subtract. And that's what that line means right there. When you evaluate A and B, you're going to subtract. So, take this out. So the antiderivative that you just found is the 4's cancel and you're left with x to the 4th power. So you're going to evaluate x to the 4th power at 0 and 4. So I'm going to take my handy dandy parentheses, wherever there's an x, I'm going to put a big set of parentheses, minus a big set of parentheses. And my 4 goes here. I'm going to put that in, hold on a second, the yellow, and I'm going to put that here. And I'm going to color this green, and I'm going to put that right here. And that's where it always goes. 4 goes here, and the 0 goes here. Now, I'll do this one for you. 0 to the 4th power is 0. Now, when you see 0 here, that's a good thing. Is it going to be 0 all the time? No. So whatever that number is, you're going to put right here. What'd y'all say? Who was that? I thought I heard somebody talking. 4 to the 4th power is what? 16. What's 16 minus 0?
16.
So the area under this curve and 4x to the cube, we know, looks something like this.
256.
I'm sorry. I was thinking of 4 times 4. Thank you for catching that. I just did the same thing y'all do. 4 times 4 is 256. Thank you. 256. So the area under this curve from 0 to 4 I don't know why this thing keeps doing that. From 0 to 4, this area right here, this is inches, then this is 256 square inches under this curve.
Are they always going to give you the 0 and the 4?
They always will, yes. If it's a definite interval.
Okay.
Now the word problems may tell you from 0 to 10 years. The word problem, and then you put 0 to 10. Let me show you something else. I need to show you something else while we're on definite integrals. Talking about symmetry. Let's take this same, now we're leaving business calculus here and going into engineering calculus, but I have to because you need to know this. Let's say f of x is equal to x cubed. Basic x cubed function that looks like this. Okay? And the definite integral, I'm going to say the antiderivative of x cubed from -3 to +3 dx. There's 2 ways to do this. Can anybody that with some calculus behind them tell me, or antiderivatives that remember, can you tell me what are the 2 ways I can do this? Anybody want to take a stab at it?
Can't we just do what we just did?
Yeah, do what we just did by the basic laws, but there's one other method. Anybody want to take a stab at it?
0, 3, 0, -3.
Now, how'd you know that? Okay. Since it is symmetrical, he said, just do 0 to 3 and do what? Do 0 to 3 and multiply it by what? 2, because what is the distance between 0 and -3?
3.
So these 2 right here are what? What do you call something that looks the same? Symmetrical. If you have a symmetrical graph, or if something is symmetrical, you can do it from -3 to +3, or you can say 2, I'm going to say, or 2 times the antiderivative from 0 to 3 of x cubed dx. Now I want you to do both of those. I want everybody in here to do both of those. Do x cubed from -3 to 3, and then do 2 times 0 to 3 of x cubed. Either way, you're finding the area of the green area. I'm glad y'all said something about not doing antiderivatives. Y'all wouldn't be lost when we get to substitution. But in fairness, the 130 students, we only got barely 2 substitutions, so everybody would be lost, I guess. So I'm going to have to go through substitution in depth a little bit. But that proves old squeaky door gets what?
Oil.
OIL. I'm surprised you ain't tried to figure out the 2 pronunciations of OIL. Perfect way and the dumb southern racist way.
Earl.
There you go. Earl. Dumb southern racist. That's why you don't say Clemson. You don't say Clemson because then you're a dumb racist Southerner. You got to say Clemson. Y'all ain't never listened to the ESPN guys on ESPN? Here we are in Clemson, South Carolina. Never heard of Clemson before. My daughter just transferred up to Clemson. She did 2 years down at the College of Charleston and got sick of being away from home, which I told her she would, but she said she was going to live down there forever. Needless to say, after I told her that I was right 1,500 times, she transferred, and now she's Clemson. And she put a picture. She's at Tillman Hall, and she took a picture of her. What's the place? What's the field? Bowman Field. She took a picture of her on Bowman Field, and I said, "Way, yeah, you're at Clemson," and I put CLEMPSON, and I had some smart aleck on there say something. I hate transplants. Anyway. We got a dang old creek that goes through our farm. And it's a big old creek. It's about 50 to 75 feet wide, and it's about 3 foot deep. So it's almost a river. And it's called Generosity Creek, which means Little Pines. It's an Indian name. Generostee. Yeah. And the people that live and grew up in the area call it Genusty. That's the way they pronounce it. Genusty. Genus. But people that come in transplants, they come in and call it Generosity. And if you don't call it Generosity Creek, you're a dumb, ignorant, racist Southerner. I'll be all right. I take medication. Did y'all get it? So, what's the antiderivative? Okay, this thing's going to have to go. Oh, shoot.
What does it say?
Screen resolution has changed.
You did it now.
I don't know. But I did hit my foot, and I ain't going to hit my foot again. All right. So, x to the fourth. Weasley, Pendleton, are y'all still good?
Yeah, we're good.
Okay. X to the fourth over what? 4?
Yep.
Evaluated at -3 and 3. Oh my God, a fraction. I might as well quit. So, to the fourth over 4 minus parentheses to the fourth over 4. 3 and then -3. And then 3 to the fourth power is going to be 81. Somebody help me out. 81 over 4 plus what? Be a minus. Be a minus what? Now, the reason you have to be careful here is it is symmetrical. All right? Technically, what is this area doing to this area? It's basically canceling it out. You see what I'm saying? Because this is under what?
Under 0.
It's under 0 because it's negative. This one is what?
Above.
Above. So this one actually cancels this out. Now that's what the mathematics tells you. So you have to be careful and discern that you're actually saying, okay, well, I know it cancels out, but they're asking for the area, so we're going to go ahead and put it in as a plus. But we do know that there are opposites, so they do cancel out. So I'm going to just put a negative right here, and I'm going to put 81 over 4, and I'm going to put a note. Areas do cancel out equal to 0. But what's wrong with that? Area cannot be what?
0.
Area cannot be negative. All right? So that blows that out of proportion. Now what this does is this tells you graphically that the two areas do what? They cancel out. But in real world, area cannot be negative Therefore, you take this as a positive, and you get 162 over 4, and somebody, what does that come out to be? 4.5? I don't know. What is it?
40.5.
Huh?
40.5.
So the area, the green area here is 40, let's say this is inches. Okay? Then 40.5, this area right here is 40.5 square inches. Okay? Now you got to realize these two things. One, you've got to realize that area cannot be negative. If area cannot be negative, you're going to get an area. The mathematics and the signs tell you here that the areas, they do cancel out because 1 is negative and 1 is what? Positive. So you got to make that distinction. Now the best example to have, now the reason I showed this example is because of that, but a good example of an area under the curve would be like this. Well, no, not that one, because that's the same one. Hold on. Now, this area, and let's say that this one has a horizontal shift, 1, 2, 3, 4, 5. So that's going to be x squared minus 5. I'm sorry, x minus 5, quantity squared, sorry. And y'all learned that back in 109. X minus 5, quantity squared. So f of x, our antiderivative, and we can't do that now. Well, we can. Yes, we can. X minus 5, quantity squared, dx from, we know this is 5, so let's go from 4 to what? 4 to 7. From 4 to 7. Now, do we have to go from 4 to 7, or can we go from 5 to 7 and multiply it by 2?
Yeah, you can do that.
Go from 5 to 7 and multiply by 2. Because these two are symmetrical. So go ahead and do that one. Because first thing is you need to discern whether you can do this antiderivative or not, or do you have to use algebra first before you can do the antiderivative? Yes, sir. No, I'm off the clock right now. I just stopped talking. So, yeah.
That last one I evaluated to where instead of doing the 3
Did
and
2.
3, I did the 2.
Mhm.
So I got 27 on that. Very good.
Okay, x to the 4th over 4, 3 to the 4th, 0 to the 4th, and then multiply that by 2. What did I get?
40.
Mm-hmm.
I'm not quite sure.
I must have multiplied something wrong. What did you get on that one? From 0 to 3, what did you get? Did you get 40.5? Yeah, there's neither of us do. Let me do it right quick. Y'all keep working.
At first, I originally got 27, but then I realized I set it up completely wrong.
Okay. From 0 to
That's
3.
what Grace said.
I got 27.
Oh, did you set it up right? Because I set it up wrong.
I have no idea.
Let me look at that one again. Hold on. So x to the 4th from 0 to 3. From 0 to 3, so that's going to be 3 to the 4th divided by 4. And 3 to the 4th is going to be 3 times 3, which is 3 times 3. That's 81 over 4. Yeah, 81 over 4. And multiply that by 2.
I think he did it the way that I originally did it. Did you just plug in 3 to the...
And what's 81 divided by 2?
We did 3.
81 divided by 2 should be 40.5. I got the same answer.
Okay, where did he get x to the fourth from over there, and then at the original function it's x to the third?
The original function was x to the third.
Yes.
Yeah.
So where
Take the antiderivative of x to the third. Did you take the derivative?
I don't think I did the antiderivative.
Yeah.
I think that's what
Yeah, this is the antiderivative of x to the third. The original was f of x is equal to x to the third. Here it is.
yeah.
And I took the antiderivative of that, and that's right here.
Yeah, see what we did is we just plugged in right there. We did basically I guess the derivative.
Y'all did it right here. Yeah.
Yeah, we plugged it in
Yeah.
right there.
That's why you got the different answer. Okay, here's what I did. Okay, right here. All right, first of all, when you plugged in, here it is, 3 to the fourth over 4. There it is. 3 to the 4 is 81.
I didn't get 3.
Let me see what you did.
Let's see, I got.
Yeah.
I got.
Here it is. This is okay. Take the antiderivative of that. You got to add the fourth.
Well, I was gonna do this one times 2, right?
No. You can't do that.
Like, do that.
No, what's your last name?
I thought,
What's your last name? Brown's Law of Mathematics. You can't use Brown's Law of Mathematics here.
wasn't that the order over there?
You take the antiderivative of x to the third. Take the antiderivative first. You can't multiply it. That 2 is going to be multiplied by the antiderivative when you get it. That's the antiderivative. And then what happens, okay, now what happens to that 2 and that 4?
Well, they should just go into 1/2.
Well, x to the fourth over 2. Yeah, that's right, x to the fourth over 2. Now, you've done that. Now evaluate, draw your big line.
Now I plugged in 3. and
Okay,
then
what's
6.
3 to the fourth? That's not the answer.
That's right.
You did the same thing I did.
I got you.
Okay? 3 to the fourth is 81, not 27.
So I did it right.
You did it right, you just, the 27 messed you up. And that's easy to do, so just to be careful on that. Because you don't think in terms of to the third power, a lot of people don't. Okay? All right, so here we go. How do we take the antiderivative when we don't know how to use substitution? I'll say it one more time.
Foil.
You use algebra, FOIL method. I will not pronounce that. You pronounce it however you want to. I won't be one of them dumb racist Southerners. And push my walker over here. I can't see. That thing will not let me get in there and change that. Y'all see that? That nothing. It's nothing easily in Pendleton. Y'all don't see it. It's something that's come up here. So I don't know how to get rid of it. I'll just don't worry about it right now. As long as it's not on this screen, I'm okay. All right. So we're going to FOIL, or shortcut number what? Number 2. A minus B quantity squared is equal to x squared minus 10x plus what? 25 dx. And we're going to evaluate that at 4 and 7, or you can evaluate it to antiderivative from 5 to what? From 5 to 7 of x squared minus 10x plus 25 dx. I'm going to erase this. Yes, ma'am.
How can you do it from 5 to 7? Because that's the difference of 2, and then 4 to 5 is the difference of 1.
Well, it's supposed to be 2 on both sides, so that would be
Should be 3.
3. Thank you. Thank you. So it should be symmetrical on both sides. So I wrote it down wrong. It should be 3 to 7. Is that what you're saying?
Yes, sir.
Okay. Thank you. So that would be 5 to 7. So 3 to 5, that would be 2, and then it's got to be 2 on both sides. All right. So I'm going to take the derivative, the antiderivative. So that's going to be x to the third over 3 minus 10x to the 2 over 2 plus 25 x to the 1 over 1, and I ain't got to worry about plus c, because when we're dealing with when we're dealing with definite integrals, the c does not apply because you're plugging in something. All right, so here we go. X to the third over 3 minus 5x squared plus 25x. Evaluated at whichever one you want to do. I'm going to do 2, and I'm going to go from 5 to 7. So if you want to go ahead and multiply the 2, or you can do it at the end. I do it at the end because it's a whole lot easier to multiply 2 times a number than it is to multiply 2 times x over 3. Don't do it. So I'm going to take parentheses cubed over 3 minus 5 times parentheses squared plus 25 parentheses minus parentheses cubed over 3 minus 5 times parentheses squared plus 25 times parentheses. Now I'm going to put a bracket right here. Why am I putting a bracket right there? Somebody tell me why. Because you got to be careful with that minus symbol out there, okay? So I put a bracket. Whenever you have a minus symbol, whenever you're subtracting, you better put whatever you're subtracting in parentheses or brackets so you remember not to mess up if it has multiple terms. That's an algebraic thing. You always do that. All right, now I'm going to take my handy-dandy blue marker, and I'm going to plug in a 7 here, a 7 here, and a 7 here. And I'm going to take my red marker, and I'm going to plug in a 5 here, a 5 here, and a 5 here. Now I'm going to go over here, and I'm going to do the math, because some of y'all have to have a little bit of refresher on how to use fractions, because you depend on that calculator too much. And that's why you can't make change at the cash register, because you depend on the calculator too much. All right, so 7, what is 7 to the third power? 243? What is it? Yeah, 343. I always get that one mixed up. 343 over 3 minus 7 squared is 49 times 5. That'd be 250 minus something. What does it come out to be? 243? I don't know. Just what is 7 squared? 49 times 5.
Yeah.
5. Over 1 plus, what are y'all talking about? Y'all keep talking while I'm talking, and I'm going to keep calling you out, whoever's doing it. Okay? Think of it like this. If you came up to me after class and was asking me a question, and I started talking to one of these people, what is that?
Rude.
Thank you, whoever said that. So whoever's doing it, you're being rude. Don't raise your hand. Hey, I saw that. Plus 25 times 7. Now, I asked you what 25 times 7 is, and you punch it in a calculator, but if I asked you what 7 quarters are, you tell me it's $1.75. Figure that out. So, 175 over 1. Oh, that's supposed to be over 2, isn't it? No, they're both over 1. Now, why did I put them over 1s? Because I got to get a common denominator, because I'm not going to depend on the calculator, because I want to be able to make change when I run a cash register. All right, so 5 to the third power is 125, right? Somebody check my math. 125 over 3 minus 5 to the second power is 25 times 5 is 125. 125 over 1 plus 125 again. Or, is that right? 125? Well, we know that those two cancel, so you can go ahead and cancel these two because they have a common denominator. So you can cancel those two. So we've got 343 over 3 minus, well, 1 will go into 3 times. And 3, that's going to be 3 times 15, that's going to be 5. Bring you 1. 3 times, that'd be 13. Bring you 1. Be 735. Somebody check that for me. 3. And 175 times 3 be 15. 2 and 5. Somebody check those two for me. And then we're going to minus 125 over 3. So basically we got 343 minus 735 plus 525 minus 125 over 3. And the 525 minus 125, that's 400. So 343 minus 735, what did I say, 400? Over 3. 343 minus 735, let's see, 343 minus 743. I'm thinking,
392.
thank you. What does it come out to be? Negative what?
392.
392. So that's going to be negative 392 plus 400 over 3. Now let's see, I think we can do this. That would be 8. So somebody give me a decimal of 8 over 3. What is that, 2 and 0.67?
Yeah, 6 repeating minutes.
6, 8? 6, 7, something like that. 6, 7. Now we got to multiply that by what? 2, because we got 2 sides. So somebody, what's 2.67 to multiply by 2? 5.3 square, and if it was inches, we'd go inches squared. So under that curve, that x cubed, that x squared curve, we got 5.3. If it was inches, it would be square inches.
Shouldn't it be a 7 over the 3?
I have no idea. No. 400 minus 392 should be 8. Unless I did some math wrong. Check my math. Did you get a 3 here or something?
I thought I did, but I could have been wrong.
Somebody check me. Because I made that problem up. So you can check these numbers right here to make sure I changed those correct right here. What's 3 times? No, not those. These right here.
I think this might be a stupid algebra.
You're right.
Okay, of course I am.
Sorry about that.
Would that negative out front not affect the negative 125 because that turned it into positive 125?
Did I not?
Because you see how you canceled them, but if you do it in order.
Okay, is this going to be a negative?
No. Do you see what I'm saying? Up in the second.
Right here?
Yeah, no, up one more. Do you see how you canceled those two, negative 125 and the positive 125? Would that not change, that negative out front, would that not change it to a positive?
It would change this one to a positive and this one to a negative, and they still cancel.
I see what you're saying.
It's got to change each term. You change this to a negative, this to a positive, this to... They're going to cancel no matter what.
I see what you're saying now.
It's a good question. I didn't even... Yeah, that's a good question. Now, do you see how... I mean, this is... The math is tedious. The math is 20% of the problem. Algebra is 70% of the problem. And 10% of the problem is actually taking the what? The antiderivative. So, you need to be able to do these things. Okay? All right, let's try nerd.
Is this your first time taking through
Oh, let me show you the indefinite. I've already shown you the indefinite. The indefinite is one that you have to put the C with. Well, this is the indefinite I'm fixing to give you. Well, yeah. All right. Antiderivative of 3x minus 2 over square root of x dx. Okay, now just forget about the calculus. Why do you need to forget about the calculus? Because you got to what to this problem before you start? You got to rewrite it. got to use your algebra and rewriting skills to even get this in a problem that you can take the antiderivative of. Again, that's one of the things that you should know. We already ready to quit. Now again, I'm going down to the elementary steps, and I'm putting in all the exponents because, again, if you get confused with either the derivative or the antiderivative, put the exponents there that are there so that way it'll help you out. And even with the algebra, when you're using the distributive law and you're adding exponents, you get, that's supposed to be a negative, sorry, negative 1/2. Right here. There it is. I forgot to put it. So this is going to be 3x to the 2/2 minus 1/2 minus 2x to the 0 minus 1/2 dx. And again, we're still working on algebra. Antiderivative 3x to the 1/2 minus 2x to the negative 1/2 dx. Now you're ready for the calculus. Yes, sir.
Where did the x come from on the subtract 2x to 0?
Okay, what's this term right here?
2.
2, but what's beside it? Nothing. X to the 0.
So you should add an x.
I put an x to the 0 so you'll see to add the exponents.
But in theory,
It's not usually there,
it's
no.
not really, okay. Yeah, that was confusing.
Well, sometimes it's confusing, sometimes it helps people, so I throw it out there. Either way, you should get this answer right here. Now, what can I do here to make things easier? Pull out the what? Pull out the constants. Now you just have to take the antiderivative of x to the 1/2 and the antiderivative of x to the negative 1/2. Now, just to make sure that everybody understands, I'm going to make this smaller. I'm going to impress y'all.
I'm going to impress you.
What? Y'all are impressed, aren't you? Y'all better be. All right, so now I'm going to take that. I'm going to go down here and I'm going to say 3 antiderivative of, well, I'm going to go ahead and take the derivative, but I'm going to combine 2 steps. I'm going to say x to the 1/2 plus 2/2 over 1/2 plus 2/2 minus 2 x to the negative 1/2 plus 2/2 over negative 1/2 plus 2/2. And now you can start adding your what? Plus c, because I've taken the antiderivative. As soon as you take that antiderivative, you need to get in the habit of putting plus c out there. Now we just did the calculus, and let's mark that, because I want you to see something when I finish this problem. Okay, so 3, that's going to give us x to the 3/2 over 3/2 minus 2 x to the 1/2 over 1/2 plus c. And that's going to give us 3 times 2/3 times x to the 3/2 minus 2 times 2 over 1 multiplied by x to the 1/2 plus c. And what happens to the 3's? They cancel here. That's right, class. And that gives us as a final answer 2x to the 3/2 minus 4x to the 1/2 plus what? And that is an indefinite interval. Now, why did I mark the yellow? Somebody tell me why I marked the yellow out of all of that. That's the yellow is the calculus. The rest of it is what? Algebra. Same thing with your definite intervals. Same thing with your any rules that you learn in calculus. The calculus is only 10% of the problem. Now, a lot of teachers don't know, and people don't understand why they keep failing calculus or why they suck at it. The reason they suck at it is because they suck at algebra. So if you suck at calculus, you need to worry about your algebra, because that's probably where the problem is. Grande?
Yeah, you're absolutely right.
Yeah, you're absolutely right. Whatever. All right, I'm going to take the roll, so y'all go ahead and do the packing up rude stuff. Go ahead and do that now. Okay, all 3 of y'all are here, so I'm just going to put enter, check. Now let's check the whatever campus this is. This is the penalty. Okay, clap.
Here.
Okay. Corley. No Corley.
It's awful big.
Mr. Crawford is not here.
Here. I'm easily,
Crawford's
but I'm
not
here.
here. I'm gonna make you.
I'm here, dude.
Field.
I hate you. I'm leaving.
Good. Leave. Cupcake. All right. Field.
Here.
No Field. Frederick. Frederick is here. I just added him. He has his own Skype. Granger is here.
Yep.
Hethorn.
Here.
I hope, did I say Heathorn? Is it Heathorn or Hethorn?
It's Heathorn.
Okay, Heathorn. Okay, Lehrer. Lehrer. McKenna.
Here.
And Miller.
Here.
Right? Next is the Easley campus. Evans. Evans. Griffin.
Here.
Holiday. Holiday, not here. Cole.
Here.
Nethercutt.
Here.
Phelps, not here. Abels.
Here.
Okay. Hold on a second. Y'all can go ahead. Mr. Granger, you still there? No, he done left. Yeah, y'all good to go. I called y'all. Y'all good to go.
Thank you.
Uh-huh.
Thank you.
Mr. Miller. Okay, Miller was here. Yeah, there he is. Okay. I don't see his first name. That messes me up. Okay. I'll thank everybody. Okay. Any questions for Pendleton? Easily done cut out. So, y'all good, Pendleton?
Yeah, we're good.
Was this good for y'all to go over since y'all hadn't had it, or?
Yeah, we both took it last year, but we withdrew. He took it at Clemson, and I took it here with Lamb, and so it's just been almost, I guess, a semester since we've seen it.
Okay, well, so it's helping you to go over it a little bit?
Yeah, for sure.
Okay, good. Yes, sir.
I need help on that last step.
Okay, which one?
The three, where you cross the threes out?
Yeah, that's 3 over 1.
Well, how did you get there from the one before?
Okay, this 2/3, this 3/2, when you divide by a fraction, you multiply by the what?
The reciprocal.
So I just brought it up here and flipped it 2/3. I just flipped it.
Okay, alright.
Same thing here. When you divide by 1/2, you multiply by what? 2 over 1.
You just kept the 2? Okay. I
The
see.
2 was out here. The 2 was out here, and then I brought this up, and it became 2 over 1, so that's 4.
Okay. Okay, I got you now. I'm still brushing up.
I think, that sounds like you're brushing up.
I had
And that's
been
fine.
run like 6 years.
That's what this is for.
Yeah.
So when I send you that homework, when I put the homework up tonight, make sure you go over it and make a note of which ones you need me to go over, okay?
Okay.
Because I will go as fast as y'all need me to go, but I'll also go as slow as you need me to go.
Yeah, because at Clemson, they don't really give you...
No, they don't.
The way that they taught it is they give you this book, and then they just run through it, and if you don't know it, you better learn it.
Yeah, you learn it on your own.
Yeah. So we had this big book that tried to explain it to us, but didn't do a good job.
Yeah, I know. I went there. I know. You ain't got to tell me.
Yeah. Well, I appreciate it.
Yeah, man. Have a good one.
You too.